Hi guys, I thought I was overdue doing a complete go to woe build video. So with the new Cali board that I've got, I'm putting together a full it's a 50 watt EL34 build using my chassis design, and so I thought it'd be a good one to actually document from beginning to end, and that's what the video that's about to follow does. So hopefully this gives you, if you're considering doing one of these builds yourself, a bit of a guide, if you like, and certainly documents the process that I go through. Do bear in mind, of course, that all of my boards come with pretty much everything you need from a documentation perspective, right? So things like a schematic, a wiring layout diagram to follow. If you're not really comfortable following schematic diagrams, you can follow that, and a bill of materials, right? So all of the components and so on that you need to order. Certainly for the PCB, I supply all of that, and I'm always available on email or messenger or any of the communication channels, right? So if you've got any questions about your build before, during, even after, all right, you want to tweak anything, I'm always available, happy to answer questions. And any of the guys that have built amps using my PCBs will know that I'm generally pretty good at getting back to people with my thoughts or answers to questions where I can help. Happy building, guys. I hope you find this video informative. Cheers. Okay guys, so this is the chassis for the Cali that I have designed, and it's a standard Marshall small box size, right? So it'll fit into a small box head cap. The differences is that I've got enough room on the front here for 9 pots, right? So you can, with all the 2 gains and 2 masters and depth control and so on, you'll struggle to fit that onto a standard Marshall configuration. So it's got extra holes here, a large pilot light, which I like for the large lamps, like one of these guys, like this. I'm going there, like a fender kind of style. Always look cool. And I always used, for space on these small chassis, I often use the 3-way switch here, which is off, standby and on. So rather than using 2 switches, you can use 1. Transformers are already on this, as you can see, bolted in. This chassis does have space for 4 12AX7s, but in the Cali build we actually only need 3. So we'll probably end up using these 3. I'll put a spacer over the top of that to blanket out, and obviously the 2 octal tubes there. This will be an EL34 50 watt build. Underneath you can see the transformers are bolted in. This is how you want to start, right? So if you've got the chassis and you've ordered your transformers separately, you'll need to drill the chassis out to suit, or if the chassis has already got the holes in it, which this one has, you can obviously put the transformers in there yourself. The other thing to note on this Cali chassis is it's pre-cut or pre-drilled for the Cali PCB, right? So here's one here, which has been prepared earlier, beautifully, all soldered and ready to go. So this is going to go in here, and you can see the standoffs on the PCB here. They're actually already pre-drilled into this chassis, so you won't need to muck around drilling holes, because those standoffs will just fit perfectly for this board. Okay, just a comment about the tube sockets and the pots, right, for the chassis that I've designed. These are the Belton octal tube sockets. I recommend getting these. These are the kind of the gold standard, if you like. Some people, do you put them in this way? No. Put the octals in from the inside of the chassis, like so. The notch, which is in between pin 1 and 8, put those facing the back of the chassis. like so. Alright, and then you'll obviously screw these in. These are M3 sized bolts for the preamp tubes, right? The novels. These don't go in from the inside; they have to come in from the outside. So they'll come in like this, that way. Okay. So with the space here between pins 1 and 9, you'll have that facing the middle of the chassis, right, and so on. Again, M3 size bolts to secure those in. Just a comment about the pots. I do use in all these chassis. Here's one here. These are cut for the Alpha M8 size pots, right? So it's an 8mm bushing, not the 3/8 inch size ones. They are larger and they won't fit. If you have 3/8 inch size pots, you can use the chassis, but you'll need to drill each of these holes out and make them slightly bigger. Alright, so with the 8mm size pots, you'll see that they'll just fit straight in here, nice and tight, and there you go. Done. Alright guys, so we've got the tube sockets in. Right, here's one of the spacers. You can get these off Mouser. I'll put a part number up in the bill of materials, but that's a nice little spacer that just, if you've got any holes that you're not using, good spacers. So what we do now is I want to put the face plates on. So here's one of the plates that we've got. These are done locally for me by an engraver to my design, and you can see, right, surprise surprise, they match the chassis perfectly. So I often get emails from people saying, can you do face plates for me? And I always say yes, but only if you're using my chassis, right? Otherwise the holes won't match. And it never ceases to surprise me how many people don't necessarily realise that there's a connection there. I can't do face plates for just any old chassis, unless you send me the chassis design. So the way to get these on is basically, the way I do it is just to get a couple of parts and secure them, right? So here's a cliff jack that I'm going to use for the foot switch, which is going to go here. I'll just put them in and just do it finger tight, because you tend to find that there might be a little bit, you don't want to do it too tight until you get all the other bits in, right? So once that's on, I'll do the rest of these, do the front as well, and then we can start doing something about these transformers. Okay, so we've now got the face plates on, and they are literally held in place by all the components, right? All the jacks and switches and so on. They're all just finger tight at the moment. I don't do these all really hard until you've got the plates on and you know that everything's in alignment, as you find if you do it up too tight at one end, you won't have any adjustment. What we've done here is my trusty apprentice has followed the layout diagram and completed all the pots, right? So this is the input, obviously. The guitar goes in here, gain pots all the way through to power amp control. So this is presence and depth here. So all the pots are in based on the layout values there. And if I turn this around, you can kind of see how that's starting to come together. Three-way power, as I mentioned in one of the earlier sections of this video. So off, standby, on, all in one switch. I will put the part number for this on the bill of materials, because they can be, when you look at the Cali switch, there's a million of them, right? So I'll save you the hard work. There's impedance selector obviously in here. I've got these from I think I've got these from Mojo Tone actually, but standard impedance selector, you'll see these all around the place from amp supply places. The chassis is
pre-drilled or pre-cut to fit one of these in, right? You can see it's just finger tight at the moment. Space here for the effects loop. So this is standard 1.5 inch spacing, so it will fit the Metro loop, or of course one of my loops here, which is ready to go straight in there like that. Okay people, so just by way of update, we've now got a bit of the chassis wiring done, so I thought we'd run through where we're at before we move on any further. So what we've done is I've actually, in the previous video, I had the 3 preamp tubes all together here. I've actually moved, this chassis has got room for 4, I've actually moved the phase inverter one over. The reason I did that, because in terms of proximity to where it's going to be wired to the PCB, you could go either, actually, but I moved it here because this is going to use the normal AC heaters, which will be coming from the power tubes, whereas my first 2 preamp tubes are going to be using 12 volt DC heaters. So I wanted to keep the phase inverter pretty close to the AC, the 6.3 volt AC, which is why we moved that. So while we're looking at these, you can see what we've done is just wired pins 4 and 5 for 12 volt DC. This comes off this one, and at the moment this wire is going all the way to the back of the chassis. We'll talk about that in a second. Coming down here, you can see this is how I do the pins on an octal socket, right? So basically pins 4 and 6 I bend down so that you can put the screen resistor kind of out the way, leaving pin 5 free for the grid resistor will, obviously be poking up on this pin here. Just be careful if you're going to bend these pins. They only bend one way. All right, you bend one way, it's fine. You try and bend them back, they'll snap. Bad idea. You snap, you'll be replacing your tube socket, which is clearly not ideal. So bend them one way and leave them. You don't have to bend them down. A lot of people don't, but I've found, I've seen this been done before, and I tried it, and it works really well. All right, so 4 and 6 I bend down. This is pin 3, obviously, so that's going to the output transformer primaries, and here we've got the regular AC heaters, and I'm running just straight wires, right? So because I always DC elevate my AC heaters, straight wire runs fine. I don't bother with all the twisted stuff. Never. I don't really. Doesn't seem to make much difference to me. And then pins 1 and 8, you can see I've bent those out the way, and we're running a 1 ohm resistor to ground on both the tubes, and obviously that helps with measuring bias. Just by way of fuse, the way I've organised my fuses here, so I'm using an IEC socket that has the mains fuse built in, okay, which is why you only see one IEC and one external fuse holder. This is for a HT fuse, and this is the mains fuse. As per the earlier video, I'm using the 3-way Carling off standby play or off standby on switch. So this side of the switch is the mains, and this side of the switch is standby. So we've wired a power transformer to this side, right, for the mains, and on this side here I've just got 2 wires ready for standby. On the Cali Jose PCB that we've done, there's actually a couple of pads on the PCB in anticipation of using one of these switches like this, so you can interrupt the main supply to the rest of the board using that standby switch there. 6.3 volt AC lamp, right, indicator lamp. So that's taken away, runs around the back, and comes into the AC heaters, 6.3 volt heaters, which are coming straight from the power transformer. You can see at the moment I've got a lot of stuff just taped away here. Generally speaking, cable runs to and from the power transformer and power switching and everything. I run across the bottom edge of the chassis. I'll cable tie all that down, right? But while I'm building, I just want to get it out the way. I use a bit of tape, a bit of gaffer tape there. The rest of the transformers are partially done, right? So this is the other side of the power transformer here. So this is kind of the, you know, the primary winds, AC, and this is all of my usable stuff. So I've just taped these out the way for now, because I'll cut these to length when I'm ready to put the PCB in. So for now, I just want to tape them off and get them out the way. We've wired the output transformer into the tubes. There's the output transformer center tap, this red one. It's going to the fuse here. Again, taping all the stuff down just for keep it out the way for now. When it's all ready to go, I'll cable tie it all neatly out the way. What else? Output transformer secondaries. Right, so black is common ground, and then got 3 different colours here for 4 ohm, 8 ohm, and 16 ohm tap through the bottom of the chassis, up and around, and onto the impedance selector. This is from the impedance selector to the speaker jack tip, and we're running the common of the OT to the speaker jack ground, and we will run, it's not on here yet, we'll run another wire from the speaker jack ground onto the PCB. I always include on my PCBs a ground pad for the speaker jack, and by grounding it there, you'll be grounding it to the phase inverter ground location, which I find is always handy for trying to avoid hum. And once we ground it to the PCB, then your OT is grounded, and obviously the speaker jack's grounded along with that. Okay, I think that's covered everything where we're at. I've got the standoffs in, right? You see them here, so that's where the PCB will go on. Obviously, we'll do the pots next, and obviously wiring from the input jack into V1. Once the pots are done, the PCB is ready to go in, and we're not far away.
So just a quick comment about populating these PCBs. In the build video, you can see I've already got a fully populated board that I'm putting into the amp. Obviously, when you start the process, it looks like this, right? Nothing to it. So just the way I go about populating the boards, you bring the components in from the top, obviously, and I solder from the bottom. Right, so these PCBs are double-sided, and they've got pads. The solder pads actually go, both sides, so you could actually solder from the top. But when I first put the board together, components in from the top, solder on the bottom, and then trim, right, with your cutters, trimming the excess legs off, and you'll end up with one that looks just like this. Now, the beauty of these boards with it being double-sided is that once the board's actually in the amp and screwed in, you can actually change components from the top. So in terms of kind of fine-tuning things like the bias, drop-in resistor, or any other tweaks you want to make to the amp in terms of cathode resistors and anode or plate load resistors, and voltage dividers, and so on and so on and so on, right? You can do all of that once the PCB is actually in the amp, because it's easy enough just to apply the soldering iron to the pad on the top and pull your component out and replace it. No sweat. Okay guys, just by way of update, a bit of progress has been made on this amp. You can see pots are all kind of pre-wired now, right? So obviously not connected to the PCB yet, but these were actually wired before the PCB went in, and I always prefer to do that because you've obviously got more room to work before the PCB kind of starts to go in there. We've started on
pre-wiring the tube sockets, look, it's up to you how you do this. Some people prefer to put the board in and then wire once it's in. You know, these just got started. Doesn't really matter. The main thing to point out here really is that we've now got all of the power section wired in, right? So the board just not coming out there because that's actually wired in now. So the important thing is that whatever power transformer you're using, the board should support it, right? So whether you're doing two-phase rectifier, a full bridge rectifier, how you're doing your standby switch. As I've mentioned previous video, I am using one of these three-way off, power on, off, standby and on switch. The way these work, this is your power switch here and this is your standby here, right? So the board, the PCB does have a standby break in the circuit here, right, in the B plus line, which is going to the standby side of the switch. The other side is going via the IEC tube socket to through the fuse there into the via the switch into the power transformer. You can see we've also got the output transformer now wired, pin 3 of each of the tube sockets, and the center tap of the OT is on the other side of this HT fuse, which also connects one side of the choke, which is this yellow wire here. The other side of the choke comes onto B+2 here, which is the screen supply. Okay, in terms of the heaters, like I mentioned last time, this is a 12 volt regulator, the 12 volt relay. With the heatsink, we've got enough juice here to actually do 12 volt heaters. So the first two preamp tubes will be 12 volt DC heaters. The phase inverter will be regular 6.3 volt AC, but I'm still going to DC elevate the AC heaters. I always do that. So the power tubes and the phase inverter will be elevated at close to 50 volts DC. These brown wires here are the 6.3 volt AC heaters. This is the center tap of the for the heaters, and I'm running that to the elevated heater pad. All my PCBs have this, right? I always build it in. You optionally can do DC elevated heaters. So sometimes I do that and all of the tubes are AC heaters but elevated. Even though I'm doing DC here, as I said, I'm still going to elevate the AC across here. Okay, what next is we will complete the wiring of these pots, get them all lined up and connected to the pads on this side, complete the wiring of the preamp tubes to the and the phase inverter into this side of the board, screw it down, and we'll be ready to do the first power up. Okay, right, so this amp is now ready for the first power up. What we have just finished and finalised since the last clip was the pots were pre-wired last time but weren't onto the board, so we've done all that. Generally speaking, I run these under and then bring them up, so you can see how they're soldered into the edge of the board here, nice and tidy from underneath. Not this one, I'll come back to that in a second, let you know why. And we've completed just the wiring of the tube sockets here, right? So pretty standard again, coming in from underneath and up. Put the spacer in there, as I talked about last time when I've moved the phase inverter. We moved it here. The reason being is that we've run, this one's running off the AC heaters, and as you can see here, this is the 12 volt DC. Alright, so DC heaters on the first two preamp tubes. I just run straight lines. Right, I've done it all, I've tried twisted, all that kind of stuff. If you DC elevate AC and you keep them away from an unshielded audio line, they're absolutely fine. Twisting is optional, I believe. I've just traced through, before we do the first power up, I have traced through all of the kind of connections here and just gone from using my multimeter, tested continuity from the live in through the switch onto the board, you know, tracing that into the mains, filter caps, through the choke into the screens. Just the kind of final check, right, that everything is wired appropriately, and most importantly, checking grounding, right? So I stick one of these leads onto the chassis, you know, put it onto audio like this, right? And that key points on the board to the ground pads. Right. All of these PCBs, you basically only need to ground them in two spots. One is at the main supply, and you often see it on the board GND1. That's that one there. So that's running to a ground point on the chassis here. The whole rest of the preamp, including the screen supply actually, is all tied together in a bus ground arrangement right to the front of the board here. And there's a single wire right at the very last ground pad here to a ground point on the chassis right here. So the whole basic preamp comes in and just grounds at the one spot there. Pretty much foolproof. Never had an issue with doing it that way. You know, no ground hum. Talk about negative feedback for a second. So this pink wire here is coming off the 16 ohm tap for the Cali. So you can get real, you know, you can get a lot of negative feedback coming in and have a quite dark amp, and obviously all the way through to the other extreme. The board allows for a three-way switch for negative feedback. This is the hair control, right? And here's the different resistors that get switched in parallel. However, for this build, I've put a variable response on the back, right? So variable negative feedback using a pot. So a negative feedback line comes off the 16 ohm tap through this pot, right, and then onto the board where it's got NFB. So negative feedback comes in here through the depth. Again, you can have a fixed depth circuit in here, no worries, right? However, again, for this build, for flexibility, we've got variable depth. So these two white wires here, this is the depth pot, they come in underneath the board and connect in here for variable depth, and so on and so forth. And you can see these resistors aren't in place because we're using variable negative feedback rather than the switch. Just before the powering up as well, I've actually got the tubes in. Alright, so I don't like to power amps up particularly without the power tubes in, because basically what that means, you're putting no load on the power transformer and the voltages will be very high, and I don't like that, because I think it often these, you know, your filter caps and so on are sized to deal with a certain voltage, and if you've got no current draw on the PT, the voltage would be very, very high and could go over the tolerance of these things. So if you check all your wiring and you're pretty confident with it, I say stick the tubes in and then do a very measured power on procedure, which we're about to do. Okay, so we're ready for the first power up. There were a couple of things I failed to mention in the last clip. I'll just quickly touch on them. The reason we've got said this was coming in over the top here, this is a phase inverter, so this is coming off the treble wiper. This is just temporary, right? I would always shield this if I was doing this. I've just stuck it in here for now. What's going to happen here is we're actually going to run shielded cable, like this black stuff, all the way across the top over here to the loop. Right, this is where the effects loop's going to go. It's not in yet. So it's going to come off the treble wiper into the solid state effects loop, and then out of the loop into the phase inverter. So the reason, this is just temporary, right? And the reason I've got that like this, and the reason I have no switches in yet either, right? So this is just for channel switching, bright caps and all that. I always try and get the amp up to a point where I can turn it on and test it before I get complete. The reason for that is troubleshooting is a lot easier, I find. Get the minimum configuration in, verify that the amp's good, and then start putting all your icing on the cake. Right? So if I wire all this stuff in and put it on the board, and then I finally power the amp up and there's an issue with it, there's a lot to unwind. I mean, this would be a lot to unwind if I have to pull the board out, but better to have minimal configuration in. And then verify that that's good, power the amp off, make sure everything's discharged, and then you can progress on and complete the rest of the amp. Okay, so this is just the 8 ohm resistive load, right? So I've got the impedance, like I said, at 8 ohm. I'm not even going to run any signal through the amp yet, but it's just a habit. You don't actually probably need that, but I'm going to do it because it's just a nice habit to have a load on your amp, of course, everyone knows that. And we've got 240 volts AC coming in here. So I have actually, as I mentioned in the last clip, been through and kind of verified with the multimeter that everything's grounded as far as I can tell, and that the power connections are actually connected correctly. So without further ado, I'm going to turn this on, not all the way up, right, just power on, but the amp will be in standby mode, and let's see what we have. Okay, first thing you'll notice, if you just bring the camera over here, Danny, is we have an indicator lamp running. That's a nice sign and always reassuring. There's no smoke coming out of this amp yet, which is also reassuring. I can't smell anything, and it doesn't feel like anything's getting hot just yet. If we come down here and have a look at the tubes, this is the next thing I have a look at, I can see they're glowing, right? So the power tubes are already glowing hot. As you can see, the phase inverter is also glowing, and quite pleasingly is also my preamp tubes. Well, certainly one of them is anyway. I can't quite see the second one. That means we are getting some voltage down there. Okay, that second one might be an issue there, so we'll have to come back and have a look at that. I'm just going to check a couple of things with the multimeter voltage readings. We're not going to run it out of standby yet. And the first thing I'm going to check is that with our 12 volt supply here, whether we've actually got 12 volts. And I can do that by simply touching a ground on here and on a 12 volt pad. And you can see, if you can see that multimeter on the camera, I've got 12.16 volts, so that's happy days. Right, so this PT has a 15 volt AC wind on it, which is used especially for this purpose, right? So 12 volt regulator, it gets rectified here, 12 volt regulator, and it's just a 12 volt supply for the 12 volt heaters, and obviously for the relay. It's a 12 volt relay. The very next thing I'm going to check is the bias voltage. We'll always try to remember, before you take your amp out of standby, to check your bias voltage. If you've got a separate bias wind. This power transformer does, right? So it's got a separate bias tap on the PT. That bias tap comes into the board here, gets rectified by that diode. This is a bias adjustment, obviously. What we should end up with is a negative voltage, which is apparent on the grids here, right? The grids to the power tube. So if I just touch that grid, and I'm measuring minus 16 volts, so that's good. I'm getting the bias voltage, right? It's not zero, probably not where it needs to be. You're kind of looking for minus, 30, 35 volts, something like that. So let me just adjust this. Let's see what happens. Not sure which way yet, but we'll figure it out. Okay, minus 19. I might need to change the bias resistor here to get a bit more. If I go back the other way, what do we get? Yeah, minus 13. Okay, not getting quite enough bias voltage there. That's kind of normal. A little bit of fine tuning when you first get the amp up. So the most I can get is minus 19. Probably not quite enough. So it means that I think it's this resistor here, R40 on the Cali board. I have to check that, but I'm pretty sure. We'll need a lower value because it's washing off too much voltage. I want to get that a little bit higher. Now let's see what is going on with this tube here. So if I just measure, make sure I come down here and measure that I've got 12 volts at the first preamp tube. Yeah, 12.14. The second one's the same. I'll just turn this light off and see if what I can see. Oh yeah, it's glowing. Okay, sorry, it's just that bright light on it. I couldn't see. So if you have a look now, I don't know whether that's coming through on the camera, but we have all of them up and running. Okay, I'm going to power off. Check that bias, and then we'll be ready to take it out of standby. Okay, power on again. We've moved the bias resistor down, so we get a lot more. Actually, get a lot more bias voltage coming through here now. I'll just check it, and that's AC. I want DC. And on the grids we've got minus 40 volts, so that's plenty. Yep. Happy days with that. And I'll take it out of standby and see again. Let's see what happens. Okay, coming out of standby now. I'm checking the power tubes because I do not want the red plate. Minus 40 volts should be okay though. Okay, I've got a bias voltage. Happy days. Pretty high, but that's where we can adjust, right? So that's 58 millivolts, or milliamps, because I'll convert it into amps. Okay, I've come right down here onto the very first preamp tube, and I've checked the plate voltage on the first preamp tube. It's 160 volts. So I'll just go all the way to the end, right? I just want to check that the power's coming all the way down. Next plate, 246. Okay. It's obviously the cathode follower. Screens, we've got 470 volts. So plate voltage is sitting at 475 volts. Alright. Okay, so what we're going to do now, guys, is we're actually going to run a signal into the amp. So, just to recap with the bias, we had to drop this drop-in resistor here. I actually had it at 120k to begin with. I've got it, as you can see, right, it's down to 22 now, but that gives me pretty much perfect range. Perfect adjustment range with respect to these EL84s, which are now running. I'll show you the plate voltage as we turn this on. So the amp's in standby, coming out of standby now, and if we just check the plate voltage here, 496, right, she's right up there, so it should be a pretty robust amp. Back into standby for a second. There's one other thing I wanted to demonstrate. Now I did say, remember that we haven't finished all the switching and so on, and the reason for that is we want to make sure the amp's golden before we get too far ahead of ourselves. But I did want to, the other thing that I always check is the relays. Alright, so is relay switching okay? So I've got a little crocodile clip here. The amp's in standby, right? So even in standby mode, this is getting 12 volts, so the relay will be able to be energized. And the K1 pad here, K1 is the relay, it just needs to be grounded, right, to energize the coil and make it switch. So let's have a listen. Can you hear that? Relay is definitely clicking. Alright, so that's good. Put that away. Okay, back to what we need to do now, right? We're going to run a signal into the amp to test it. I've got an 8 ohm resistive load. Alright, this is running to a large 100 watt resistor on the bench. Here, I'm going to input a sine wave, and so if you just move the camera up here, it's my oscilloscope, right? An essential tool I have found. I don't know how I built amps before I got this, to be honest. This thing can actually generate, it's a signal generator and 2-channel scope all in one, so it's pretty handy actually. So what I can do here is I've set up, alright, so here's a sine wave input. Alright, so what you actually want, you don't want it that big. I just turned it up so you can kind of see it. Right, I'm going to actually drop it down to about 150 millivolts, give or take. 160 is fine. You can see it's a 1 kilohertz signal, pure sine wave. Alright. Now, so the generator's on, so I'm now getting sine wave actually into the input of the amp here. On the oscilloscope, I'm going to turn it off. Now I'm looking at live signal. Right, so this is now my probe. Right, so if I click the end of the probe, I can see it's making some impression on the scope. There you go, look at that. Right, so with the probe, we're going to go, I've just got it straight into the speaker jack here, right? So I always work backwards. So you might be lucky. You might actually have amplified signal at your output from putting a sine wave on the input. If you don't, then start to work backwards, right? And start to troubleshoot. But you know, go for gold right at the outset. Let's just see. Okay, the amp's in standby. Now I've got all the kind of depth presence, tone stack, all just at midday. I've got the master volumes on 0. And I've got the gains at 12 o'clock. Right, so take the amp out of standby. Now power on. What we're seeing on the scope here now is actually measuring the output here. So I'm going to now bring up the volume on the amp. Oh, look at that. We've actually got a nearly 8 volt peak to peak signal. Oh yeah. So we're all happy days here. So let me just play with the gain. If I bring it down, we've got a pretty nice sine wave there. Bring the master up. Yeah, that looks pretty sweet, doesn't it? Nice wave there. And if I bring the gain up, you should find that it starts to grind up. Oh yeah, look at that. Sweet. Okay. And just a little bit of an output test, so let's just see if we can get close to 50 watts here. Oh yeah, look at that. That's output clipping there, output stage. So I know there's a little bit of shape on that wave, but getting 66 volts peak to peak before it really starts to clip. Awesome. Alright, back to standby. Okay guys, so I actually just brought the amp into my music room here. Just literally took it off the scope per the last clip, brought it straight in here. Got it running into this Marshall 4x12, it's got all greenbacks in it, 16 ohm cab obviously. And look, I just want to hear it, right? Before we gun up, you can see switches and stuff's not in here. It's going to be hardwired onto the second channel
obviously haven't got the relay activating, but just want to hear what the amp sounds like before we get too carried away with finishing it. So without further ado, let's take it out of standby. Yeah, she's nice, and there's no hum coming from the power transformer there. So the gain's quite low here, it's just on about 9 AM, and here's our master. Let's bring it up. Oh yeah. Okay, sounds pretty, sounds quite nice, yeah, gorgeous. See, I've still got tone stack, just everything at midday. Just brought the gain up a little bit here, so what are we at? Just coming up to 11 AM. Okay, now we've confirmed that the amp is fine, right? Remember I said we wouldn't complete all of the rest of the bits and pieces until I'd confirmed that the amp was just working okay. We've moved on now and implemented all the switching here, so I'll just go through this, and then we'll go to the scope and I'll show you kind of what this actually does to the sine wave. It's quite interesting. So what we have in the Jose Cali build, right? So there's two gains, gain 1, gain 2, and then switchable masters. Each gain pot has a 3-way bright switch, right? So these are center off and then each way. This is 1000 picofarad and 2200, or 1 nano and 2 N2. Same here. 1000 picofarad and 2200 picofarad. So obviously in the middle position, the bright cap is not coming into play. This way, the 1000 picofarad comes into the circuit, and this way the 2200. Likewise here. So these cascade, right? So gain 1, gain 2, the audio signal cascades through. So with these bright switches, you can actually do quite a lot to shape the tone. This is the channel switch, so it's just 2-way. First master and second master, simple as that. And then on each of the masters is the 3-way gain style, and these are 3-way switches. Again, center position is no clipping. So on the board here, and you can see this here, we've got two types of Jose clipping here, right? So these are 20 volt Zener clipping, and this is the MPSA06, just transistor clipping. This is more mild. 20 volt Zener is a bit mild, but you'll still notice it, right? Saturation to burn.
and this is quite hard clipping, quite compressed. And the board is behind this capacitor here, but it repeats, right? So it's 20 volt and the transistors, and 20 volt Zener and the transistors. The switching here allows you to configure for each master whether the clipping is completely off, whether it's transistor clipping or whether it's the Zener clipping, and same on this master. Okay, so let's have a look at what this means on the scope. So we've got the sine wave coming into the front of the amp, and I'm, as per one of the previous segments of this video, I am monitoring with the probe on the oscilloscope. I'm just monitoring the output. So I've got a 24 volt peak to peak signal here, and I'm just flicking between channels. So I've got no clipping on here, and I've got no bright caps on. So no bright cap on gain 1, no bright cap on gain 2, and no diode clipping. And if I flick between the channels, and I've just done that there, you can see the voltages changing between the two channels, right? So obviously with 36 volts here, this is louder, this is not as loud. Right, so if I just start moving the bright caps into play, you'll see what it does to the waveform. So this is the first bright cap on gain 1. Look at that. Okay, turn it off. You can see what that's doing to the waveform in terms of, you know, distortion, right? And the second one, both of these have been switched on the 2200 picofarad, just to demonstrate what you can see the bright caps do. Right, leave those on, and now I'm going to put into place the diode clipping. Look at that. Alright, look what it does to the waveform. No clipping and clipping. This is why you get a perceivable volume drop when you put like a sat switch on a Friedman, and you hear the volume goes down. It's because look what it's doing to the waveform. That's even more, right? So let me just give this a bit more. That's the 20 volt Zeners there. No clipping. That's the transistor clipping there. So 7.6 volts one way with the transistor clipping. 13.6 with the 20 volt Zeners clamping it down. And with no diode clipping on altogether, 63 volt. You know, it's a huge difference. Okay, just one final thing. You can see I don't have the loop in here yet. Right, this is where it's going to go. I will actually do a separate video for the installation of the loop, because that procedure is identical regardless of the amp that you're putting it into. So I think I'll do a separate clip for that. So at the moment I've still got the treble wiper here coming straight into the board. As I've mentioned earlier, what we will do is we'll run shielded coax from the treble wiper across to the FX loop, out of the FX loop into the phase inverter, but I'll do that in a separate clip. Okay guys, so now that we've put the bright caps on and the channel switching and the gain structure with the clipping, I brought it straight back into the music room. Amps on standby, and we'll see what it's done to the sounds. Right, so coming out of standby here, I am on the normal channel here, or first master if you like, and I've got no clipping, no bright caps on or anything. That's pretty much just how the amp sounded last time we had it in here. So what I'll do is I'll bring in some of the bright caps, and you can see what it does to the sound, and a quick look at the clipping. Across to the second channel here. masters, you can obviously set different volume, right? Now I'm on the second master. I'm going to bring in the clipping, right? So this is, I think, 20 volt Zener. You get a volume drop. That's to be expected, which is why you want you have a master to balance it. Now this is starting to grind up now. Jose.